Video-based learning content is increasingly consumed in mobile environments with varying screen sizes. However, one of the main limitations of mobile learning is the small screen size, which deteriorates the learning experience and decreases the effectiveness of learning with too small font sizes, content-heavy lecture slides, and complex graphics to digest in a mobile environment. The existing learning framework also highlighted the importance of such visual design factors in learning. Inappropriate font sizes of learning material impose unnecessary cognitive load and lower judgment of learning. Excessive amount of words is another factor that increases the cognitive load and information overload. Image elements can also increase cognitive load by splitting learners' attention. However, one of the existing video learning content is originally designed for desktops with wide screens. Moreover, existing studies on mobile video-based learning lack consideration for video production engineers and designers, who are direct stakeholders of lecture video design, being involved in the content design process. Our research is in threefold: content analysis, interviews, and prototype system. To better understand the challenge, we first analyzed 681 video frames from 108 video lectures. The lectures are selected from the top MOOC courses list in 2019 released by Class Central and include MOOCs from Coursera, edX, and FutureLearn. The analysis result shows that the current video lectures are not suitable for mobile learning environments with too small font sizes and dense text, which are not readable and digestible on small screens. We adopted most strict and most lenient guideline since there was no single rule of thumb guideline. From 86 to 98% of the collected video frames had too small font sizes, and 60 to 82% had too dense text, violating the design guidelines. This analysis result reveals the distribution and issues of the current lecture design. We also conducted formative interviews with 6 video production engineers to investigate current practices and challenges in content design for mobile devices. The engineers considered how the content they created will be displayed on mobile devices. They mentioned an increasing number of learners watching a video lecture using various portable devices and different learning environments. For this reason, they tried to adapt the content to fit mobile devices by resizing, repositioning, and segmenting the content. The main design factors they considered include font sizes and the amount of information on mobile screens. Based on the interview results, we developed a prototype system to support video content design process for mobile devices. Once the lecture slides designed by video production engineers are input to our system, then it displays analysis results for the input learning material based on the existing design guidelines, whether the input slides comply with the guidelines or not. For example, for this lecture slide, our prototype system displays the statistics for font size, word count, and image count. This slide contains 95 words in 9.75 point with one image. Then on the next column of the table, it shows diagnosis, in other words, whether the design of the slide complies with the existing design guidelines or not. The primary contributions of this research can be summarized as these 3 points. First, a content analysis that reveals a landscape of design elements of current video-based learning content and automated inspection for design guideline compliance rate. Second, an exploration of challenges and current practices of video content design process for mobile learning environments through interviews with video production engineers. Third, a prototype system that supports video production engineers with computer-guided video content design. We expect that the quality and accessibility of video-based learning content can be improved based on our research. Please refer to the paper for more details.